Hello, everybody. Good afternoon. Thank you for taking time to come to this session today. I know it's been a very long day. Reinforce, the first day of Reinforce, and you had lots of choices and lots of places you could be. So I'm glad that you chose to be here, and I hope to leave you with some good content and some things to think about as it comes to your security story and what you're going to do with containers. So my name is Scott Ward. I'm a Principal Solutions Architect. I work on our External Security Services product team. This is the team that owns GuardDuty, Security Hub, Macie, Detective, and Inspector. So I work in a couple different ways. I work directly with our customers to help them understand how our services work, take feedback from them on what they would need from our services, and work with them to understand how they can use our services specifically in their AWS environments and based on how they're trying to meet their security goals. I also work with our product engineering team. This is the team that's actually building and writing the software for our services to make sure that what they're building lines up with what customers need and expect, and help guide them with features that would allow a customer to get more value out of our services when it comes to security. I've been with Amazon or AWS for the past 21 years. I have been in this role for about a year and a half, but I used to work on our partner team at AWS as a solution architect as well, helping security partners build their solutions on top of AWS to help customers with their security goals. And prior to that, I worked on our internal financial systems team, actually working to build and customize and scale and operationalize that service and all the fun that goes with scaling with a very large and quickly growing e-commerce company. Mrinal Shah was going to be the customer co-presenting with me today, but Mrinal had a last-minute emergency come up and will not be joining us today. I will do my best to represent his slides towards the end to help tell a little bit about the HBO Max story as it comes to container security and using some of our security services. So I'm going to spend this entire presentation today talking about new features that we have launched recently, focused on container security, helped us show a little bit about how they work and how you might use them so that you can take that away and apply that to your organizations. We have lots of customers around the world in lots of different industries and lots of different sizes of businesses who are using containers as part of the way they differentiate their business, how they're modernizing their applications, or how they're moving into a more of a microservice or a continuous integration, continuous delivery approach. And one of the things we hear from our customers regularly is how do I secure my container workloads on AWS? Containers are new. I don't necessarily understand how to secure them or what the right ways are to secure them. And customers are asking us a lot, what are the best practices when it comes to securing container workloads on AWS? And so for this session, I'm going to highlight all the recent services that we've built and released that are focused on container security as far as threat detection goes, and make sure you understand how they can be used and how they can line up with best practices. So to start with, I'm going to focus on the Amazon GuardDuty Kubernetes protection feature. This is an extension of the GuardDuty service. We announced this a couple months ago. This is focused initially on your EKS clusters. So to start off with, just a quick refresh on how GuardDuty works as a whole. It's a single-click enablement to turn on GuardDuty. You can, with a single click of a button or with an API, you can enable the GuardDuty service. GuardDuty is integrated with AWS organizations, so you can have a delegated administrator account where you can have visibility around the findings from all your other member accounts that have GuardDuty turned on. GuardDuty is natively integrated with all of the AWS data sources that it needs to be able to do its threat detection for the features that it supports. Those are automatically integrated into the GuardDuty service. You do not need to turn on any of the log sources that GuardDuty supports to be able to get value out of GuardDuty and to have it detect threats. If you do want to have a copy of those log files, you do need to turn on those log file services and set a storage location. GuardDuty is able to detect threats against a couple of key spaces. One, Amazon S3, so the data events coming out of your S3 buckets, your instance workloads, your EC2 instances, accounts and users. So thinking about your IAM keys or the temporary credentials related to roles and the activities happening against those. And now container workloads with the support for EKS. And so for EKS and Kubernetes, GuardDuty is using the Kubernetes audit logs as its source of data to help generate and create threat detection for your EKS clusters. So just a quick overview of the Kubernetes audit logs and why they exist. So every Kubernetes cluster, when it's launched, has a control plane API. This API is used to perform administrative tasks against your cluster, to query information against your cluster, as well as allows resources within the cluster to communicate with each other. Customers often use the kubectl CLI or making REST calls to interact with this API. So because this API is allowed to interact with your cluster, to manage your cluster, to make changes with your cluster and learn data, learn information about your cluster, it's a very powerful API. So it requires the right amount of attention to make sure that the interactions with that API are ones that you trust, that you care about, and that you can detect malicious activity happening against that API. And so it's really useful from an operations, a security, and a compliance standpoint. And so that's why the Kubernetes audit logs exist. They give you control plane visibility around who, what, when, and where are interacting with your Kubernetes cluster and the API at any point in time. If you're familiar with CloudTrail, I look at this as CloudTrail for your Kubernetes cluster. It's giving you that level of information around all the API interactions that are happening with your cluster. And so with GuardDuty's Kubernetes protection and the ingestion of those APIs, we're able to identify and show you different types of findings related to threats in your environment. We do policy. At a high level, it's around policy, malicious access, and suspicious behavior. So policy-wise, we're going to be looking at the configuration of that cluster. Are there cases where you have made the dashboard for your cluster publicly available? Have you made the API itself publicly available? Have you done something to grant anonymous access, or has somebody granted anonymous access to your cluster? For malicious access, we're looking at unknown or untrusted entities or entities that are known threats that are interacting with your environment. This could be somebody coming from a Tor exit node. It could be somebody who is defined in our threat intelligence as a threat actor. It could be somebody who is doing discovery or exfiltrating data out of your environment. And then there's also suspicious activity, things that are abnormal for a Kubernetes cluster, things like executing commands within a Kubernetes pod or launching a container with privileged access within your cluster. So at a high level, those are the different types of items that we're looking for when we are ingesting the EKS audit logs and generating findings within GuardDuty. And then at the bottom there, we have all of these different finding types that we use to categorize the findings, and they align with the MITRE ATT&CK framework as far as what type of activity is happening and being observed in your environment at any point in time. I want to quickly highlight these EKS audit logs. Just like all the other log sources that I mentioned for GuardDuty, these are automatically ingested into the GuardDuty service as soon as you turn this feature on. So whether you're running 1 or 100 EKS clusters, or you're bringing up and tearing down clusters on a regular basis, GuardDuty will automatically start consuming the audit logs for those clusters for the length of time that those clusters are actually up and running. You don't have to do anything to turn that on or apply any additional configuration for GuardDuty to do its work. So a little bit of information about the types of findings that are generated for Kubernetes clusters by GuardDuty. First of all, this is one finding that I've broken into 3 different screenshots just to be able to show the detail at the right scale. First of all, the high-level overview, we're going to give you the details about that particular finding. So the finding type, in this case, we have a case where there's been successful anonymous access into the cluster, a brief description about that particular finding, and then an overview about the resources. So in this case, we'll tell you when we first saw this. If we continue to saw it, we'll update it at with the last time that we saw that, as well as the ID about the information about the account and the particular cluster that this finding is for. We will also start to give you more details about the actual cluster where we found this threat. So giving you details about the workload itself, giving you more details about the cluster itself, its configuration, some of its attributes, which network it's running in, as well as the user details that were interacting with the cluster and the API at the time that this threat was observed. And finally, we'll give you the actual action that was made against your cluster. So in this case, the Kubernetes API call that was made. So you can see more information around what the call actually looked like and what it was attempting to do against your cluster. So these are all intended to give you more context so that you can then decide how you want to take action against that particular cluster. So speaking of taking action on the findings, we have published several public guides on how to go about remediating the findings that GuardDuty is producing for your EKS clusters. The first document listed here are the GuardDuty public documents. So for every finding that GuardDuty generates for EKS, we have a page that talks about what that finding means, why we generated it in the first place, and steps you can take to remediate that. Some of those remediation steps then point to that Amazon EKS security best practices document that I also have listed here. This is a public open source document that we've created that walks you through how to actually go in and change your Kubernetes configuration to align with best practices, and in many cases to remediate the cause of these particular findings, whether it be making the actual API itself private, even talking about how to whitelist if you do need to make it public so that you're only allowing certain access, or how to do other things to change your environment so that you are reducing the threat. Some of the other items listed here are talking about rotating credentials, backing out any changes that the malicious actor may have made. In some cases, you may need to patch and redeploy that container. What I would definitely recommend is as you get into these remediations and how you want to understand them, figure out anywhere you can where you can automate that response. It may take you a couple of times to manually go through how you implement this change, but then look into steps where you can actually automate any sort of repeatable steps that you might be doing as you're responding to findings. I would also use this as an opportunity to get more on the preventative side. If you are finding that you are consistently remediating clusters due to misconfiguration, look into seeing if you can invest further up into the deployment stage of a particular cluster and implement some security checks around those configurations before they're ever deployed in the first place, helping to enforce your security controls from the very beginning. So where can you use the GuardDuty Kubernetes protection? So the obvious answer is in your production environment where you're running that production workload. GuardDuty is going to be watching for threats that are happening against all of your production workloads. But I mentioned earlier, GuardDuty is integrated with AWS organizations, can provide you visibility around findings that are happening in all of your accounts, in all of your organizations. There's actually opportunities to use GuardDuty in a lot more situations besides production. First, I'll look at the sandbox scenario. There are many customers who every engineer or every developer gets their own sandbox AWS account. That's their place where they can play around with things, work on their development and any tests that they're doing or any science projects before they start moving things into the actual development pipeline. GuardDuty can be turned on there, looking for EKS configurations or EKS threats that might be introduced by the developer in their sandbox environment. It might actually give you some early insights into where somebody might be taking the wrong approach or might be looking to move something into production that's going to be wrong or present a potential threat to your production workloads. We also have lots of customers who use a deployment pipeline to be able to build and test and deploy their containers before they get into production. You can actually have GuardDuty enabled in every one of your non-prod environments, as well as your production environment, in every stage, looking at the key EKS audit logs for that cluster as it's being moved through these different environments, so that you once again get early insight into any threats that may be introduced by that cluster in the lower environments, allowing you to potentially catch and make those configuration changes before it ever gets into production. And then with organizations, you have the ability to have all of these findings from all of these different environments visible in one centralized console. In this case, I have it in the security team console, so that they have visibility across all the environments and they have the ability to respond and help you remediate across all of these different environments. Okay, the next place I want to hit is the feature we announced today, which is the Amazon GuardDuty malware protection feature. Very cool addition to GuardDuty, and some very specific areas where it's going to give you some insights specific to your containers. So at a high level, what is this service or feature as a whole? It's a fully managed malware detection service. So it's just like all the other GuardDuty features. You turn it on, you accept the service link role, which is giving additional permissions to be able to do the malware scan, and then GuardDuty takes over and does all the work to help detect malware and surface findings for you. It's focused on EC2 workloads. So the trigger will be any EC2 related findings that GuardDuty creates. And then if you have the malware detection protection feature turned on, we will automatically then scan that EC2 instance for malware and report that back as a finding into GuardDuty. And we use a third-party engine as well as a combination of our own work, our own machine learning, and our own threat intelligence to be able to detect and report back on the malware that we found. Can detect lots of different types of malware. These show as a new finding in GuardDuty. I'll actually show you what those findings look like in just a moment. So we talked about the fact that this is scanning EC2 workloads. And so if you have an EC2 instance that's generating EC2 related findings such as Bitcoin mining, communication with a command and control server, or your EC2 instance has now started scanning other instances or other pieces of infrastructure, those are all potential indicators that there may be something malicious going on, and you need more insight and context into what might be generating that particular finding. So we'll scan the EC2 instance, but this service is also container aware. So if we find malware that is attributed to a container running on an EC2 instance, we will actually report back a finding that gives you insight into the actual container. So if you're running ECS, EKS, or self-managed containers on an EC2 instance, we will be able to give you findings related to those container workloads that might be containing malware. And then this is all agentless. You don't have to deploy any security software in order to get this to work. You just turn it on and you start using it. So let's talk a little bit about how this works so you can understand what's going on under the hood and how this agentless aspect focuses or fits in. So to start with, you're going to accept a service link role when you enable the service. And this is going to give some permissions, including permissions to KMS. So we can support non-encrypted EBS volumes, but we can also support EBS volumes that are encrypted with a customer managed key from KMS. If you are using the default EBS service key, we cannot support that. So keep that in mind as you're looking at adopting this service and how you're currently using EBS volumes on EC2. So we have a scenario here where a customer has an EC2 instance running. They've got a couple of EBS volumes attached to that. Those EBS volumes are encrypted at rest with KMS keys. GuardDuty has generated a finding that is related to that particular EC2 instance. We have malware protection turned on. At that point in time, what's going to happen is that GuardDuty, through its permissions that it has, is going to create a snapshot of your EBS volumes, share a copy of that snapshot with the GuardDuty service team account. We will then launch in the GuardDuty service team account, compute resources, launch new EBS volumes that are based on the snapshot that was shared with our account, scan those EBS volumes for malware. If any malware was detected, that will then result in a new finding in the GuardDuty service. We will then delete the snapshot out of your account and terminate the compute resources that are running in the GuardDuty service team account. Sure. So question was, does that include active memory or just EBS? That is just EBS. So since there's no agent, we don't have visibility into the memory at this time. It's just whatever we see on the EBS volume based on the snapshot. Yeah, we have a question was on file system support. I don't have them memorized yet, but we have a long list of file systems that we support for this. And we're doing a deeper dive session tomorrow. We'll highlight the file systems. Okay, so the findings that are generated by malware protection. So on the left, I have an EC2 generated finding, which in this case we have detected there's Bitcoin mining happening and communication happening on that particular EC2 instance. That's triggered a malware scan. So on the right-hand side, I have a malicious file finding from GuardDuty. So the first thing I'll highlight there on the bottom of that right-hand side finding, the threats detected. We're going to list out the malware files that we found, as well as the location of those malware files. We will also, you will be able to see that these are related to the same instance. So we'll still report back the EC2 instance that the malware was found on, and you will see that that relates to the original EC2 finding that was generated. We also will allow you to correlate based on the finding ID. So every GuardDuty finding has a unique finding ID. So on the left-hand side, we have the original EC2 one. And on the right-hand side, we have the malware scan one that actually has an attribute called the triggering finding ID. So if you are looking through all of your findings, you have a malware finding and you want to figure out which of the GuardDuty findings actually triggered this, you can attribute that back based on the finding ID. You can actually just, in that little plus next to the finding ID, you can actually click on that and it would put the filter into the console and it would bring up the original GuardDuty finding as well. And then as I mentioned, it's container aware. So this is an example for an ECS cluster. So we found malware on an ECS cluster. We'll give you all the details about that cluster. The cluster itself, the tasks, and the containers that we're running on that particular EC2 instance for the malware that we detected. So you have an EC2 finding that's originally been generated, you have a malware finding that's been generated, and you have very specific details on which container image that's related to, so that you can go out and take the appropriate action to isolate that container, to replace it, to remove it from service, and remediate these threats, as well as potentially start a forensics investigation into how that malware got there in the first place. Okay. The next area I want to focus on is around Amazon Inspector. So the Amazon Inspector service was relaunched at reInvent 2021, so December, a few months ago, a completely new version of the Inspector service, and it launched with support for Amazon EC2 and container images stored in ECR. So Amazon Inspector, just like GuardDuty, is a single-click enablement, one click of a button or one API call to turn it on. Same integration with AWS organizations where you have the ability to see, from a delegated admin, to see all the findings across all of your accounts. Amazon Inspector, this new version is continuous. It is focused on continuously scanning your resources for vulnerabilities. It gives you contextualized findings, so the detail about what was the finding that we found, and depending on if it's EC2 or a container image, some additional details for EC2. We'll talk about if it's network reachable or not and actually adjust the score. For a container image, I'll show you we give a lot of detail around that actual container image and all the places that we found the malware, so you can go and very pinpoint exactly where you're going to take action to be able to patch that particular container image. And then all of the findings from Inspector are available in the console. They're also available in AWS Security Hub. If you use Security Hub, Inspector will automatically send findings to Security Hub. You can also consume findings out of Amazon EventBridge. You can actually see these findings in Amazon ECR as well, if you prefer to use ECR or if you don't want to give your developers access to Inspector. And then we have lots of third-party partners who are also integrated to consume information out of Inspector and help you with managing your vulnerabilities. So specific to containers, because that's what our focus is today, what is Inspector, how is it scanning those container images? So first, Inspector is going to go and retrieve that actual image from ECR. Then it's going to actually crack open that image and it's going to extract each layer that is part of that container image definition. We're then going to look at the actual operating system of that container image and look through the package repository of that operating system, looking at the installed packages to determine if there's any vulnerabilities. We will also go beyond the package manager for the operating system. We will actually look through the rest of the file system on that container for any other files that would contain code that would have vulnerabilities in it. So we have in-inspector support for 10 different programming languages where we can help identify vulnerabilities that are in that container image beyond the normal package manager of the operating system. And then everything that we've extracted from that container image is compared against our vulnerability database to be able to ultimately render findings back to you in the inspector service. And those findings will be based on a critical, high, medium, or low severity. So it's important to understand a couple things around the configuration for container scanning when it comes to inspector. So ECR had its container scanning feature for multiple years. That was free. It was based on open source CLAIRE. That still exists. It's what we call the basic scanning here on this screenshot. But when you turn on Amazon Inspector and you enable functionality for ECR, it enables what we call enhanced scanning. So this is the inspector paid feature for scanning your container images. So that's the first thing to be aware of when it comes to the configuration. The second thing to be aware of is you can influence how often Inspector is scanning your container images. So the first option is to just scan on push. So you can configure that feature, and every time you push a new container image to ECR, we will inspect it, we will report back the vulnerabilities, and then we will never look at it again. But you can also configure continuous scanning. And when that occurs, we will scan on push, and we will also rescan the container image every time we update our vulnerability database. And you can also filter that. So if you only have certain repositories you want to scan on a more continuous basis, or only certain repositories that you want to scan on push, you can put some filters in for specific repositories. A little bit more on the continuous scanning. So we recently enhanced this so you have some flexibility on the time frame. So you now can choose lifetime. So we will scan that container image or rescan it every time we have an update to our database for as long as that image is sitting in ECR. But you can also scope that down to 180 days or 30 days. We have some customers who are updating their container images on a very frequent basis, and they don't have a need for longer term scanning because that image is already out of date by the time we get to that 30 days or 180 days. So when you have this continuous scanning configured, an important thing to understand is that when we hit that time limit, so if you have something that is 180 days or 30 days, we will then flag that container image as expired or inactive. We will no longer scan it. We will take all the existing findings that are there for that container image in Inspector and move them to a closed status. And 30 days after that, we will delete the findings from Inspector. So when you get Inspector, you go in there, the first thing you're going to see is the Inspector dashboard that's going to provide some high-level summary around vulnerabilities. Specific to containers, there's a couple of areas in the dashboard I want to highlight. The first one is the ECR repositories with the most vulnerabilities. With Inspector, we're really focused on making sure that you have insight into the things that are going to be most impactful to your environment or where you can make a lot of difference when you're working on fixing and remediating your vulnerabilities. So we have the ECR repositories with the most critical findings, and then we also provide you insight into the actual container images with the most critical findings. So once again, you can go and focus on the things that would potentially have the broadest impact in how you're approaching and remediating your vulnerabilities. Also within Inspector, you can go in and look at the actual findings for a particular container image. So in this example here, I've got one container image where I'm looking at all the vulnerabilities. So this is by finding, so it's just listing every vulnerability that's been found for this particular container image. But I also have the ability to go in and choose the by layer tab. And when I choose by layer, I can then expand and investigate each individual layer and see what are the CVEs that are being reported for that particular layer. So it allows you to really get down into the fine details of that particular container image and understand what's happening from a vulnerability perspective with that particular image. So remediating. So when you have vulnerabilities present in your container images, you need to patch them. So first of all, when you delete that container image from ECR, we will immediately close the findings that are in Inspector. So your vulnerability team will always be looking at the current state of vulnerabilities that are actually active within your environment. And then when you go in and you patch that container image and you deploy a new container image, that will result in a fresh scan and a new report of any vulnerabilities or no vulnerabilities reported, depending on the current state of that container image. So we have lots of customers, as I talked about before when we were talking about Kubernetes protection, who are using some sort of a deployment pipeline to be able to orchestrate building and moving their containers along through various environments and ultimately deploying them in production. And we have customers who want to make sure that they are checking the security posture of their container images before they're ever deployed into production to make sure that they're deploying them in a secure configuration and that there's not vulnerabilities present in something going into production. So with Inspector, to keep in mind is that Inspector is an asynchronous service. So when you push an image to ECR, you can't immediately call Inspector and see what are the vulnerabilities that exist for that image. Inspector needs some time to be able to scan that image and report back the vulnerabilities. And so it's important to keep that in mind so that you can understand how you might integrate Inspector into more of an integration and deployment process. And the first thing to keep in mind here is how the information that Inspector reports back after it's done a vulnerability scan. So the workflow for a container image when it's being pushed to ECR is that after that image has been pushed to ECR, ECR will send an event to EventBridge that is picked up by the Amazon Inspector service. And that event says, hey, I have a new container image that's been pushed. Here's the repository. Inspector will pull a copy of that image from ECR, do its work to scan that image and report back the vulnerabilities. Besides reporting them in the console, what Inspector will also do is send an event to Amazon EventBridge that is a summary saying, I've completed my scan, and here's a breakdown of how many vulnerabilities I found grouped by severity type. So grouped by critical, high, and medium. So you now have an event-based signal that is coming out of Inspector to tell you that it's done with its scan and what the results of those scans were. And at this point, you have the ability to then send that event to a specific target within Amazon EventBridge. So everything here, with the exception of setting the target, is managed by AWS. So as soon as you turn on Inspector, all of this is put into place. Inspector will automatically start emitting these events, whether you do something with them or not. And here's an example of what that scan event looks like. So we can see here we've got the scan status saying that the initial scan is complete, as well as the summary of the finding severity accounts for that particular container image scan, as well as the information about the actual container image and the repository where it's stored. So what I'd like to highlight here is an example where you might use this now that you understand how Inspector is messaging about its scans, how you might use this in a deployment pipeline. Everything I'm going to share here for the next few slides is actually based on a blog that I am in the final stages of getting published on the AWS security blog. So keep an eye out on that blog over the next month for a more comprehensive write-up on this particular solution, as well as the CloudFormation and the code examples that go along with this. So we have a code pipeline here that's got a source, a build, an approval step, and a deploy step. So in this particular scenario, we have users doing a git push to a code commit repository. Code commit sends a notification out to EventBridge that a new push has happened. We use EventBridge to then hit the code pipeline source as a target. The source stage would then retrieve the results from the code commit repository. And in this particular case, it's going to retrieve the Docker file with the configuration of how that Docker image should be built, as well as the build spec YAML file, which will tell the code build service how to actually build the container image. From there, after the source retrieves its files, It'll pass control onto the build stage. The build stage will actually build the container image based on the Docker file and the information provided in the build spec. And then that image is actually pushed to Amazon ECR. Once the build is done, it will pass on to the approval stage. So the way the approval stage works with Code Pipeline is that it sends an SNS notification out seeking approval. And because it's SNS, we have the ability to actually capture that message programmatically and do something with it. So in this case, in this example, we have that approval request going out through SNS, small Lambda function to capture the key details from that particular SNS message and store those in DynamoDB. The information that we're capturing here includes the approval token for that particular approval stage. That's the unique token that has to be passed back to that stage to approve or reject it. The ID of the particular container image that we're requesting approval for, as well as key details about the pipeline itself. Additionally, after that push to Amazon ECR happens, Inspector kicks in and does its scan of the container image. And when Inspector is done with the scan, it emits that scan complete status. We set a Lambda function as the target for the event bridge rule that's consuming that status message from Inspector. This Lambda function is responsible for issuing and making the decision around approving or rejecting this container image. And the way this Lambda function works is that it has a few environment variables that are the thresholds for critical, high, and medium findings. This Lambda function will read and consume the scan complete message, extract the summaries of findings from that message and compare them against its environment variables. And if any of the thresholds are exceeded, it will make a decision to reject that container image. Or if none of the thresholds are exceeded, it will make a decision to approve that container image. And in either case, it will retrieve those key details about that pipeline that this particular container image is associated with, and then it will send the approve or reject message back to the Code Pipeline service for your container image. And if it was approved, it will then move on to the deployment step. And in this case, and in the blog example, you would actually deploy that container into an ECS cluster that has been deployed. So some cool things that you can do using Inspector to help ensure the security of your containers and incorporate it into your development and your CI/CD pipelines. So the last item I want to touch base on when it comes to new items focused on container security and threat detection is another new feature that we announced today, which is the Amazon Detective for EKS. So Detective is our threat hunting service. It's focused on allowing you to investigate detail behind AWS log sources and GuardDuty findings and arrive at a conclusion of if you have a security event happening or if a particular GuardDuty finding is a true positive and what type of response you might take to that. So Detective, just like GuardDuty, has built-in data collection, so it will automatically consume all of the AWS log sources as well as the GuardDuty findings that it needs to be able to provide you functionality, and that includes EKS audit logs. Turning it on, we will automatically consume those EKS audit logs from all of your clusters. It takes all that information and it organizes it into a graph database to help establish relationships between different entities that are in that log file. That's all automated. And then it gives you visual insights. So we give you the ability to query a particular resource, be able to see the attributes of that resource, but also be able to see what other relationships does that particular resource have, what active findings are there for that particular resource, and look at time series graphs of various API calls that were made against that resource or that resource may have made. Specific to EKS, already mentioned, we ingest the EKS audit logs. It gives you a single view of your EKS clusters and all the interactions that have happened with that particular cluster over time. Detective can store up to a year of log data. So you have the ability to go very fine-grained with a very short time window or a very long time window with this service. We consume GuardDuty findings, so if you are using the GuardDuty EKS protection, we will automatically bring those into Detective. You will be able to use those findings as a starting point to investigate further and understand what is the cause or what actually happened that triggered this GuardDuty finding. Or you can just go in and start your own search, picking a particular cluster, focusing on an IP address or a particular user, whatever might have brought you to Detective in the first place to start your search. Ultimately, it's focused on helping you get to the root cause, identifying why did this finding happen or why am I seeing this suspicious activity, so that you can then make a decision of what are the next steps I'm going to take, what are we going to do to address this. And this new feature, if you've used Detective before or use it currently, there are 2 new tabs that are surfaced as a result of this to help you with investigation. The first one is on Kubernetes activity. The second one is actually on Kubernetes API calls, and I'll showcase a few examples of those here. So first of all, this is a screenshot showing you I'm starting an investigation. In this case, I'm starting from a GuardDuty finding. So I've got 2 GuardDuty findings here that are from my GuardDuty environment. And I have one finding that's actually telling me that I've had successful anonymous access against one of my EKS clusters. I can actually then click into that GuardDuty finding, and Detective is going to show me all the entities that are related to that particular finding. And here, for example, I now have additional entities. I have the cluster itself, and I have the anonymous user that was interacting with that cluster. And I can click on that See Profile option to be able to see more information about either of those resources. So in this particular case, I've chosen the EKS cluster. It's going to give me details about that cluster, where it is, which account, what's its configuration from a networking perspective, but also going to give me information around the actual containers that were running on that EKS cluster for that particular time frame that I have set up in my search. For those containers, I can actually dig into the profile of the individual container image. If I had any security contexts defined for that particular container image, we will make those available to you as well to see what was the security context or configuration you had set for that particular container. You also, if you're doing an investigation and looking at pods, you can actually go and find out what were all the container images related to that particular pod, whether it be from the same registry or for the same particular workload, and dig into that, and once again, go down to the container image profile if you need to. So I mentioned that Kubernetes API call tab that's now a part of Detective. So in this case, I'm looking at the resource detail for that anonymous user that was showing in my GuardDuty finding. I've gone to the Kubernetes API call tab, and I've actually been able to go, I get a list of all the different API calls that were made, and then I can drill into a particular one. In this case, I'm looking at the create API, and I can see that this user was able to actually successfully create a cron job in my Kubernetes cluster anonymously. So I have a very clear indicator that this is probably a threat, and I know exactly what they've done at this point. Also, if you're doing an investigation that's based on an IP address, you could search on that IP address in Detective and be able to see what were the Kubernetes API calls that were done by that particular IP address. If you're trying to identify scope of a particular known malicious IP or suspected malicious IP. You also could be looking at IP addresses that are associated with your pods. So if you just want to know, like, I think that these are acting maliciously, or let's understand the scope of this IP address as it relates to my Kubernetes cluster, you could do a search that way. If you're investigating a particular EC2 instance, you could use Detective to help you understand what are the EC2 instances, or what containers are running on this particular EC2 instance. And from a Kubernetes activity standpoint, what are the pods that are deployed on this particular EC2 instance? Okay, so that's a summary of what we've done from recent announcements and features as it relates to container security. I want to highlight a few things on what HBO Max is doing and what brought them to moving to adopting some of our security services that relates to containers as well. So HBO Max, as we all know, a very large and fairly recent streaming service based on, or as a, out of HBO, has a large number of subscribers and is located across many different countries. So some key things about HBO Max's infrastructure. So they use EKS. They also use managed Kubernetes, or their own self-managed Kubernetes on AWS. Over 70 clusters. At peak, over 10,000 containers. They have lots of little microservices that are comprised of all these containers and all these clusters. Many, many API requests happening on a daily basis. And the log file volume is at the petabytes per year. So traditionally, what HBO Max has done for threat detection is that they've taken these EKS audit logs, but they've moved them into their SIEM solution. And then what that's meant is that their security engineers have to go into the SIEM tool and write some pretty complex queries, being able to get the right information out of these EKS audit log data. Those queries ultimately result in alerts on anomalies being created, and their service operators and the engineers get involved to investigate those alerts and ultimately remediate them. So there's been some challenges there. They're always trying to figure out what's the right query to write to detect malicious access, and have we written all the right queries, or are we missing something? So it's been difficult to make sure that they're getting all the right patterns and detecting all the right things. The queries can become quite complex because they sometimes need to join that data with other data sources, and that can be challenging in their tool. Getting real-time information wasn't always possible from this solution, and just the infrastructure to support the SIEM and getting all that data into the SIEM was complex, and it took a lot of management on their side. So HBO Max was able to move to adopting the GuardDuty Kubernetes protection feature, and it eliminated that entire middle section where they had the SIEM and they were going through and writing queries. They were able to focus on letting the GuardDuty service consume all of that log information, perform all the threat detections, using both our threat intelligence as well as our machine learning anomaly detections, and generate them findings about their Kubernetes cluster. It allowed them to be able to focus more on the resources to be able to respond and remediate those events versus having to try and write the queries and be able to go find the information that they had. So it allowed their team to be a lot more efficient, allowed them to remove the need for some more complex infrastructure or having to figure out how to write very complex queries to find that information. Now, HBO Max also uses Amazon Detective. And so it was just released today, but HBO Max will definitely be adopting the Kubernetes feature of Detective to complement what they're doing with GuardDuty already. And so HBO Max uses Detective on a very regular basis to do their investigations, to help confirm that a finding was a true positive, or to help understand more of the details behind why a particular finding was being raised, or who is the actor, or who is the particular malicious resource that might be behind a particular finding that's being generated. And then Amazon HBO Max is using AWS organizations to be able to centralize all of these findings that are being generated in their environment. So I talked earlier about AWS organizations and its integrations with GuardDuty, with Inspector, and with Detective. So they have a centralized security account where they have turned on Detective and set that as a delegated administrator, as well as they've done that for GuardDuty. And then they have those services turned on in all of the member accounts of their organization. But all of those findings are consolidated up to that security level account. So the security team has full visibility around all findings for all accounts and is able to do an investigation into findings across all accounts from one centralized location. This also enables them to be able to centralize any alerts or events that may be coming out of those alerts from a single account versus having to have those deployed in every one of those accounts. Okay, so that covers things today as far as what's new for container security on the AWS side. I really thank you for coming out today and spending time with this. I hope you found it useful and that there's something you can take away and bring back to your teams to help you improve your security posture. with containers. Please make sure you fill out the survey. This is super important to me. It helps me know how I did. It helps me know what you want to see more of or less of next time. If you have any questions, things you'd like to make sure we focus on next time, feel free to add that into the feedback. We take all feedback, and I do read that feedback when it's made available to me, so I'd love to see it. I will happily stick around here and answer questions as long as you guys want me to stick around. But other than that, thank you so much for your time and enjoy the rest of the event. Thank you.